Okay.
Good evening. I'm Megan Weintraub. This is Caroline Lee and Blake Goldberg. The boroughs that we did were Brooklyn and Queens. Okay, for a quick introduction, when one thinks about the environment, it is easy to picture an ecosystem outside of New York City, but our challenge is to make you think of New York City just as easily as you would think of like a meadow or a beach. The Welikia project knew that was happening, sorry, is a historical narrative of New York City's ecology recreating 1609 before Henry Hudson arrived on the New York harbor. This project aims to alter our way of thinking about the environment through awareness of New York City as an ecosystem. In examining the past, we can better understand and shape the city's future. Ultimately, it hopes to challenge the notion that humans are separate from the environment. To introduce this concept, we would like to show you guys the mirror web, which is a intricate way of showing the relationship between abiotic and biotic components in the environment. Each point represents a different component, and each line represents a different interaction between the two. Okay, and a quick historical overview on Brooklyn and Queens, as the history itself of the land is important to understanding the complete narrative. Brooklyn was settled by the Dutch in 1634. And the Battle of Long Island took place on August 27, 1776, which was the first and largest battle in the Revolutionary War. It was independent until 1898, when it was signed onto the boroughs by New York City, and it is currently the most populous of the 5 boroughs. Queens was settled in 1683 by the Dutch and English. In 1897, it was authorized as a borough, and in 1889, it was authorized as it added Nassau County, which is the full modern Queens as it is today. It is the second most populous borough and considered the most suburban.
Take a look at some of the beautiful maps you got to spend a lot of time with. This map is the map of New York Harbor and New York Bay and the environs. It's by F.R. Hassler, who was the superintendent of the U.S. Coastal Survey at the time, and it was from 1844, and it's one of the largest maps that we have. It's also one of the most detailed, and this is the map that we kind of judged the majority of the shoreline to, as it was a coastal survey. Also, its detail. This map's actually really large in person as well. It's 165 centimeters by 162, so it's pretty enormous, and it has kind of the most comprehensive features: ponds, forests, wetlands, beaches, shoreline, specific bathymetry, and general topography. It was really the only map that we had a good kind of comprehensive use of like the forest, which you can mostly see around the glacial moraine, that kind of ridge of hills you have through Brooklyn up there. And other than that, it should be mentioned also that this forest that we see on this map has been significantly reduced from what we expected to have beforehand, seeing as all the agriculture development had already happened by 1844. So this map is from the David Rumsey Historical Map Collection, as were a lot of our maps, and we were actually able to georeference this map with an accuracy of 42 meters, and this was using 46 georeferencing points. The next map is the 30 miles round of New York City. This was published in 1811. It's a little bit less detailed, but a larger extent. This was by J.H. Eddy. The scale in this map is 1 to 190,000. So on this map you can kind of see it's made up of different panels, and Megan took a lot of time to Photoshop out this white section in the back, which is actually the archival backing. And so though it might look small when you're looking at the whole extent of the map, it represents a great distance in actually real measurements. So we Photoshopped those out before we georeferenced to get a more accurate result. So we were able to get an accuracy of about 1,000 meters, which isn't great, but we used a lot of points, and that was 311. The next map we have is the map of the country 30 miles around New York City. And this is by J.H. Colton, and this is it was published in 1853. And this map we were able to get to a significantly better RMS error, which is the accuracy in georeferencing, and we got about 122 meters using 50 points. This map we used mainly as kind of a reference point for the shoreline for north of Queens, which was kind of not mentioned in a lot of the maps. The previous map actually was the shoreline we used for the northern section of Queens, which wasn't mentioned on the Hassler map. And this map is the British headquarters map, and it only features a small section of Brooklyn here, which is Gowanus Canal, which is right down there, mostly Red Hook, and then up there you can see Wallabout Bay. This map we actually used for this whole section. Everything featured, we used this map as far as referencing because of its date, which is significantly earlier than the rest. This was made during the Revolutionary War by the British troops, and this was in 1783. And it features wetlands, streams, ponds, shoreline, and a lot of general topography. It's very detailed and extremely accurate.
So I'm gonna go through the methods. They're pretty similar to the other two groups, but I can go through them anyway. So after our initial project of going out and collecting all these old maps, we georeferenced each of these maps to a modern shoreline, and basically what this means is to establish a mathematical relationship between the point on our modern shoreline to our estimate of the point on the old map. And Blake mentioned the RMS error. So as the distance gets larger, your RMS error is also going to increase, and we'll talk about that later. But after georeferencing, laying out all these points on these maps, they kind of conform to the new shoreline, to the modern shoreline, and this is the point in which we were ready to digitize our topographical features, which was basically to lay out points around different features on all the different maps and extract shapefiles from the layers in order to complete step 1 of 2 of the final synthesis steps. And so the first step was to synthesize layers of like features on all the different maps that we used, and basically that involved prioritizing areas between the different maps based on their date, the accuracy, and how detailed these original maps were. And once we collected these synthesized layers of like features, we compiled them all together into one large map, and I'll show you. And the final step was statistical analysis, but we'll go through that. So this is our synthesized shoreline. So for an example, we used the complete shoreline in the Gowanus Canal area and the Red Hook area from the BHQ map. And so our main base map was the Hassler map, as Blake showed you, and the upper part of Queens was taken from the Eddy map, a different map. So the synthesis of all these shorelines was this one large shoreline of the 2 boroughs. And these are our synthesized beach layers. The wetlands.
Should be mentioned that area of all the wetlands is Jamaica Bay, and it still remains a very important marine estuary, even though a lot of development's already taken place.
And these are the synthesized forests across Brooklyn and Queens. Our streams, ponds.
Kind of the concentration of all the little ponds over there. That's from the British headquarters map, and the reason we have a lot of ponds there is, I suspect, is that it was more detailed, and we probably would have seen a lot more ponds in other areas.
It was definitely the most detailed topographically speaking of all 4 maps, let's say. So. And so we compiled results after synthesizing these layers, and our complete shoreline area was about 110,000 acres, 447 square kilometers. The length was about 270 miles. The area of the wetlands was 17,000 acres, about 16% of the total shoreline area. We had 60 total ponds, 313 acres total in all areas, and about 2,600 acres of beaches and 44 miles of streams. And just want to point out that today our shoreline, the estimate is about 466 square kilometers, whereas our map shows 447. So it's just an increase in land mass, whereas everything else has kind of diminished. So, and this is our final synthesized map. These are all layers put on top of each other, all the topographical features together compiled. So.
And some discussion points. All of the maps are nearly 200 years old, and the shoreline has obviously changed drastically since then. Especially in Brooklyn and Queens, there's been additions of JFK and the other LaGuardia, and other land masses that they added, and also the natural shift of the land itself. Georeferencing also accumulates error, as we've said. But it's alleviated slightly because each of the maps have certain roads, so you can georeference to roads as well as the shoreline. The synthesized maps collaborate the best parts of each map, as our best educated guests can measure, but it still incurs error as it is only an average. This is the Eddy map, which has the largest georeferencing error. So basically, I just wanted to show that though the white lines are the streets and the red line is the shoreline. So even though overall it looks like it matches pretty well, if you look down in Jamaica Bay, this is where most of the error is incurred because the shoreline is drastically changing. So the red line is the shoreline, and the blue lines is the points in which they connect, like where they should actually line up.
So, in conclusion, cities are not the antithesis of natural ecosystems, but prove to be ecosystems in their own right. In reshaping the face of New York City, humans have replaced the diversity of the past with the diversity of the urban environment. So when we examine how the ecology of specifically Brooklyn and Queens has changed, we become aware of the land's innate propensity to support a multitude of environments, including the cityscape. This capacity should be viewed as a realistic future for New York. As citizens of a modern city, we need to embrace and incorporate natural systems. It is important to keep in mind how quick we are to drastically alter the ecology of the past when we seriously consider what is lost, what is gained, and what should be protected. The Welikia project provides us with a resource to work towards a ecologically aware future. Thank you.